Hello, and thank you for joining our webinar today. We have a fantastic discussion teed up for you today. We're going to be talking about the growing importance of backup and archive as part of a enterprise data strategy, but also we're going to be highlighting the hidden costs of backup and archive and discussing what you can do to optimize your backup and archive environment. I think we're going to have a really engaging conversation and perhaps even challenge your preconceptions with some quite eye opening data. Before we dive in, let's do some introductions. My name is Simon Robinson, and I'm Principal Analyst with the Enterprise Strategy Group. We're part of Omdia. If you don't know Enterprise Strategy Group, we are an industry research and analysis firm. We're focused on the adoption of enterprise IT. And I'm delighted to be joined today by Mitch from Spectra Logic. Hey, Mitch, thanks so much for joining us. Could you just take a quick minute to introduce yourself, your role at Spectra, and maybe a line or two on why you're excited for the topic we're discussing today?
Well, great. Thanks for that lead in, Simon. Great to be with you today, and hello to our audience. My name is Mitch Seigle. I'm the Chief Marketing Officer for Spectra Logic. And my background, I've been around the storage industry for more years than I would care to admit, but from the dawn of server attached storage as we know it today, and have worked in all sectors of the storage industry, spanning disk arrays, flash memory, and now, of course, in the tape segment of our storage industry, which is really a lot of the focus of what we will be talking about today, especially contrasting that to the actual hidden costs of cold storage in the cloud. I think the reason that I'm so excited to really talk about this topic is when I joined the company a couple of years ago, one of the main reasons that I was interested in this technology, given that it's quite a long technology in terms of its tenure in the industry, more than 70 years, is that I see an inflection in the market that is being driven not just by increasing amounts of data growth, but being driven primarily by the emergence of AI and pending regulatory changes that I believe will create a massive inflection in terms of data growth rates in the coming years. And that in turn creates a number of problems that we're actually going to talk about through the course of this webinar today. So, with that, Simon, I'll turn it back to you.
Teed up perfectly. Thanks, Mitch. Really looking forward to the discussion. Before we get to that, I'm just going to spend a few minutes providing a little bit of context for our discussion today, using some of the research and insights we see in our data. As I say, we spend a bunch of time talking to IT decision makers like you folks on our webinar today, understanding your priorities, your pain points, your challenges, your objectives, and so on. And it actually turns out that many of the key challenges and objectives we see in our research are pretty closely aligned to the topic for today. So let's turn to kind of what we're seeing in the market right now. It's obviously a very dynamic macro picture at the moment. There's an awful lot happening in the IT space that makes it a very busy place, can be a very confusing and noisy space. It's also a very, very interesting space. And I think I agree, Mitch, that we are, I think, at a kind of inflection point in terms of some of the things we're going to be talking about today. In particular, the three things that really stand out when we look at some of the challenges and objectives we see for organizations overall. First is the importance of security. Now, we see this, I think, in the headlines almost every day. Security is the number one concern for IT decision makers, and improving the security posture is the number one priority, not only at the IT level, but at the business level. This is now a board level issue for many, if not most, organizations. And actually, if it's not, then it should be. And one of the things that's really changing here is that security is evolving into cyber resiliency, right? And as a result, delivering a cyber resiliency strategy is becoming the responsibility not just of the security team, but of the entire organization. As we say, it's a team sport. And as part of this, data security, including data protection, protecting the backup and protecting data in the archive environment, is now absolutely critical. Why is that? Well, when we think about what attackers are targeting with things like ransomware, it's data, right? Ransomware is increasingly viewed as an existential threat by many organizations. Ransomware attacks are now routinely targeting the backup environment. So the question becomes, what do you need to do to ensure that your data and storage management environment across its entire breadth is cyber resilient against these evolving threats? So that's the first point. The second aspect we see is complexity. Now, let's be honest, complexity is something that has always been a part of the IT environment. But what we're seeing is that this complexity is now increasing further for many organizations. In fact, 6 respondents in 10 to a recent survey that we did said that their IT environment had become more complex over the last 2 years. And 1 in 5 said that that increasing complexity had been substantial. Now, drivers of complexity are actually wide ranging, as we see here. Uh, but what's interesting is that, as I say, we see a huge range of drivers from things like the growing security environment, the cyber resiliency environment, those threats, the sheer number of digital transformation initiatives that many organizations have going on, but also it's data issues, it's data security, it's data privacy, and it's the volume of data that organizations are generating. So often the variety of data as well is creating a huge amount of complexity. So data is very central to all of this. And I think we're going to dig into this during our discussion. And of course, the issue is not just complexity itself, it's the impact that complexity has on the business. It's a inhibitor to innovation. It slows down the rollout and adoption of new initiatives. It limits the impacts of these innovations, and it can introduce risks into the broader environment. And all of these things have cost implications, and this is another area that organizations really are prioritizing. Again, nothing new per se, but the degree of focus on cost is absolutely increasing. And organizations, according to our research, are looking to invest in technologies that can help them drive efficiencies and cost savings. And that's not just necessarily in the purchase of those technologies, it's around the entire life cycle and impact on the business overall. The third thing I wanted to highlight, speaking of cost, was some of the things we see happening in cloud. Now, we know that the public cloud adoption has been a fundamental enabler of innovation over the last decade or so. And as initiatives like AI continue to gather pace, this adoption is only going to continue. But we're also seeing plenty of challenges here, not least on the cost side, as data volumes continue to explode. The cost of storing this data in the large public clouds is seen as an issue for many. It's not just the cost of storing that data, it can be the cost of accessing this data. This can drive up costs substantially. And I think we're going to see that's where there's a lot of hidden cost. And this is where actually there seems to be some real tension. On the one hand, organizations view the cloud model as an important part of their data strategy. But at the same time, when we ask them about the challenges around public cloud storage, here we're looking at object storage, we're seeing issues around cost, around security, around compliance, performance, lack of data services. All of these things have been flagged as challenges. The final thing I'm going to just mention before we jump into the discussion is around AI. Now, of course, AI needs a mention because it's just so top of mind for many organizations. But there are also some really profound, I think, potential impacts on the data retention side. Why is that? Because, well, AI needs data and it needs lots of data. And that data is new data, obviously, but it's also historic data. Think about how we're going to train and refine models. We need historic data. So, organizations, one of the implications here is organizations are going to be hanging on to more data for longer. So, the question is, how do you do this cost effectively? How do you store data for long periods of time, be able to use it when you need it, but without getting crushed on fees? And there's actually one more further tension here because although many of the LLMs are in hyperscale and public cloud environments, enterprises have real concerns about losing control of their data. And that's motivated by a whole variety of reasons. But our research found that 78% of respondents prefer to keep their high value proprietary data in their own data centers. And actually, similar proportion, uh, almost 1 in 5, prefer to run their AI workloads on premises. So, all of these factors are kind of coming together to lead more organizations to consider or reconsider their options around longer term data retention. I think the really good news is that those organizations have more choice than ever before because of the amount of innovation we are seeing in the backup and archiving retention space. So, Mitch, thank you for being patient. I've provided a few high level observations around what we see happening in the market, but you also spend a lot of time speaking with customers as well. At a high level, what are they telling you about their challenges and how those challenges are evolving?
Well, thanks, Simon, for setting the stage. I think the research is actually pretty interesting, but in many ways, really not very surprising to kind of hear that. I mean, we're many years now at this point into the evolution of the cloud journey. And of course, there was a big rush and a major wave to move computing resources into the cloud along with all of the data associated with that. And of course, cloud has enjoyed a massive surge in growth and continues to and will continue to do so. There's no question that cloud computing is here to stay. But as with all things, we swing the pendulum hard in one direction, and people are now wrestling with that. How do we manage to get control over the costs? First and foremost, of our cloud storage. And I want to be specific that there are different types of cloud storage involved here and not speak overly broadly, but specifically with regards to backup and archival storage, which is your cold data, data that you typically write once and in many cases hope to never read again. Those costs have been unpredictable, which is a major problem for planning, budgeting, and execution, especially in an environment that's increasingly driven by operating expenses. People are purchasing in an operating expense model, and there's a high variability here with the costs of that cloud storage. And in particular, when that cloud storage is accessed to retrieve that data. So I think that that's number one. And the unsustainability of those costs. People are realizing that at the amount of data that we have today, if there's a sharp inflection upward in the amount that we will retain, whether that's by choice or by fiat, if you will, government regulation, that we will not be able to afford to do that. And that forces some tough decisions about what data of value you actually will retain. The objective, of course, in the future, especially in light of AI, would be to retain as much data as you possibly can so that AI can reason with the finest granularity to be able to uncover insights that human beings are not particularly adept at doing because of the scale of the data that they have to evaluate. So that's kind of number one, the unpredictable nature of the cloud storage costs and the fact that it's high and growing. I think the second big concern that we hear from people that we talk to on a regular basis is really the growing cyber threat environment. And I think in particular, one of the things that we need to consider is that not only is cybercrime growing on a broad scale, but it's now actually being assisted by AI, the very technology that we want to use to benefit both our businesses and our society is also available to those who wish to do our data harm and our businesses harm, and in turn our livelihoods. And so I think customers are looking and saying, how do we mitigate those threats most effectively? How do we defend our highest value data, which includes potentially trade secrets and other pieces of information that, if it fell into the wrong hands, could be very damaging to businesses and organizations in general. And so I think that that is one of the big drivers is how do we get a better control over that and mitigate those risks effectively. I think a third challenge is, of course, as we touched on, the regulatory environment itself. And I think that AI has a bit of a double edged sword, or perhaps two sides of a coin, that there's never been a bigger opportunity for technology to change literally our lives in so many dimensions, both at a business level, but also at a personal level. Our world is going to change forever as a result of AI becoming ubiquitous. But on the flip side of that, um, we see that whenever there are these huge societal changes, there's a certain amount of fear that's created by that. And where there is fear or doubt or uncertainty, governments tend to want to regulate that, get their arms around it, and make sure that bad things don't happen. And so there certainly is a natural governmental concern about the dark side of AI in terms of national security posturing, data breaches, and things that affect the citizens of every country. And as a result, we're very likely to see, and we're already seeing regulations now being put into place that will change the nature of data that has to be retained. So today, in the AI sense, we're backing up LLMs. And while they can be large, in the grand scheme of things, they're not actually among the largest sets of data out there. They're actually quite compact. But imagine a scenario in which you've got training data and governments are going to say, well, we want to understand what data was used to train your model so that we can understand whether there's a bias in your model presenting the results of that training data. Imagine lawyers, of course, being involved here, wanting to be able to do discovery in the case of litigation. Imagine AIs that provide advice to people, and those people act on that advice, and harm comes to them directly or indirectly. And so that involves litigation. And lawyers, of course, are going to want to know what the AI did at that time and, quite frankly, what it knew. And that would be discoverable information. And therefore, it will have to be retained. And so I think that those are part of the problem, along with data sovereignty issues in which the data needs to reside where people understand all the implications of that. We've seen cases in the past where governments have tried to step in and tax data that's being stored in foreign jurisdictions because it's associated with revenue created in another country. Microsoft famously went through that in Ireland not too long ago. So sovereignty and trust concerns and regulatory challenges. Then finally, the big question mark is this notion of repatriation. Now, repatriation is the term that we tend to use when we talk about bringing that cloud data back home to an on premises environment. And with respect to that repatriation, as I said before, not all data will come home to roost, so to speak, but a certain percentage. And in particular, there's an opportunity to bring cold data home affordably and reduce those overall cloud costs and start to get your arms around that escalation that we anticipate to continue. So there are questions around sustainability, scalability, enabling that data to come home because of the massive size of the data. How do you build an infrastructure robust enough, scalable enough, and sustainable enough to do that? And then, of course, well, how much money will this really save us? And part of the answer to how much it saves us is starting with how much does it actually cost us in the cloud today? We don't know with any degree of precision what it really does cost us. So we're going to try to shed light on that today.
Fantastic, really comprehensive observations there, Mitch. I think just on the repatriation side, I think there's also the aspects of, hey, are we taking our data to the AI, or is it more a sense of bringing AI to the data? I, I think what would be really useful would be to get a sense of how Spectra itself, how you folks are responding to some of these challenges and, in many senses, opportunities as well. We are seeing some, changing market demands here that are influencing strategy. And I'm curious. Many people know Spectra as a tape company, but you folks are doing a lot of fascinating work to position, I guess, tape as an essential tier for the modern enterprise, and really challenging some of those preconceptions, perhaps, about the role and capabilities of tape within this modern environment.
Well, exactly, Simon. So, as you mentioned, Spectra, of course, to those that know us, think of us as a tape company. But I think there is a broader context to it beyond just the technology, which of course we're deep experts in that technology. We bring much more to the table than just tape as a product. We look at this from a solution perspective and really at a broader level for the 45 years that we've been around, which is quite a remarkable story in and of itself, for another day, of course. Spectra really is focused on the preservation of data. When you think about where we are, we live in interesting times, so to speak, where we're seeing the dawn of what once upon a time people looked back at physical artifacts to learn about our history and our culture. And we're dealing in a very physical world. And as you look forward to the future, all of our exploration, our anthropologists will be doing what I like to call digital archaeology, and it will be based on all of the data that we're storing today. And we're moving to a world in which data is literally forever. It's created once and it is kept in some form forever. It needs to be managed. It needs to be thought of in terms of how do we protect it in perpetuity. And our mission here at Spectre, of course, is to build those technologies and those solutions that allows that data to live forever so that the scientists, the explorers, the historians that spend their life creating all of this data that will be relevant not just today but far into the future. And when I say into the future, I'm not talking about tens of years. I'm talking about perhaps centuries and even millennia. And imagine the idea that perhaps 1,000 years from now, people could actually watch a digitally perfect version of a film created in the year 2000 or the year 2025. That's really one of the neat things about what we do here at Spectra. Um, our products, though, as it relates to storing all of this data, there are really a few key technologies in addition to the automated tape libraries, which I'll kind of walk through just very briefly here. One of the big focus areas, these innovations that you referred to that we've been working on lately, is something that we call object based tape. And it's the idea of taking object storage, which is we know has been around now for about 25 years, and is very good at capturing unstructured data into collections with appropriate metadata that allows us to understand what we have captured and organized. We're creating the ability to take tape and make it accessible in an object format. And so object based tape is really the marriage of object based disk technologies, which are commonly in use today, along with the linear tape file systems that tape libraries and tape media use to organize and store data. And so what that does is it modernizes those tape libraries to make it very accessible in a cloud like model. And so that is really the key breakthrough is that now massive scalability enabled by tape is commonly accessible in the same model that people want to consume data today. If they're accessing data in the cloud today, they can access that data in a virtually identical manner using a combination of object-based disk and tape to form this object tape environment. So that's kind of a key point in an innovation. And a second additional extension of that is that now that we have that model, it can be deployed anywhere. It can be deployed on premises. It can be deployed in a hybrid cloud environment where you've got data on prem and also perhaps in the public cloud or another cloud that you may have access to, as well as now taking that infrastructure and deploying it with cloud service providers so that you can actually access tape storage directly in the cloud for the first time. And so we actually call that tape as a service, and we pioneered that and introduced that into the market about 12 months ago under the nomenclature TAPIS. I think we were a little hungry on the day that we came up with that acronym. It actually stands for Tape Archive Platform as a Service. And so now you can consume tape storage in the cloud without actually having to own a tape library or manage a tape library, which is especially appealing for smaller archives and for organizations that have never used tape technology in the past. So it's making it accessible to many more organizations today than we've ever seen. Just very quickly, when I talk about tape libraries, I tend to take for granted that people know what we're talking about. But I think that there's really two kinds of people in the IT space today, Simon, those that use tape and those that don't know that they use tape. And while I say that tongue in cheek, those that don't know that they use tape are actually realizing that because there is tape behind all of these cloud storage platforms. So if you think about services such as Amazon's Glacier cold storage service in the cloud, most of that storage is in fact stored on tape technology. It's just accessible through a cloud front end in a similar manner to what we're doing with our own tape as a service. And so tape is ubiquitous, tape is there, it's not always directly visible. What these libraries tend to look like is what you see on the slide in front of you now. We offer 4 different, product lines targeting 4 different ranges, and so just to give you an idea of how big these are, at the entry level, we have our Spectra stack library system, which is roughly a 10 petabyte library in scale. It is our rack-mounted library, so it goes nicely into many data centers that are focused on rack scale computing and rack configuration. We have our Spectra Cube library there, second from the left. The Spectra Cube is our latest fully modernized library, and it is ideal for edge to enterprise data center applications. It can literally go anywhere. It's designed to go through standard doorways, so it makes it easy to get it into departmental environments if there's a need, IT closets, even data centers of any size, and also to use it in environments that tend to be low in terms of the human resources necessary to care for it. This is all completely self-serviceable, thumb screw replacement, and remote hands can easily do any service necessary on the library in 5 minutes or less while the library remains in full operation. Third from the left, our Spectra T950. This is an enterprise library. It scales out to 8 frames. You see the first frame there. And this library actually can store currently 180 petabytes to give you an idea of the capacity of that library. The Cube library, I forgot to mention, is a 30 petabyte library. So to give you an idea of the scale of capacity. And then our flagship, all the way on the right, the Tfinity Plus series, which actually can scale out to 45 frames and handle more than an exabyte of raw capacity of data. So this is for the largest enterprises and organizations on Earth. And of course, we have many of these out there in very, very large data environments. So when we talk about tape as a technology, you get a sense of the massive scale that is able to then keep up with the coming data explosion that we anticipate in the world of AI. Then finally, just to kind of talk about the benefits of object-based tape versus public cloud storage itself, I think the advantages are that it's first and foremost as easy to use as the cloud because of these object storage interfaces. For example, it is Amazon S3 and S3 Glacier compatible. And so applications that use those interfaces for object storage can directly use our object-based tape without changes. It's much more affordable. We'll talk about that. There are no hidden fees, which is really a focus that we're going to uncover here in just a moment. It's more performant. These libraries have a great streaming capacity to provide that data to you. And so tremendous performance when you go to not only write the data, but to retrieve it. It's much more highly secure in addition to various encryption methods, both for the library access and for the tape media itself. The biggest benefit is that it provides a physical air gap. In other words, the data, once it's written, is removed from a tape drive, stored inside the library, or it can be ejected and stored offsite if you prefer. And when it's in a disconnected state like that, it is simply impervious to electronic incursions and is really immune. So it forms really your last best defense against cyber crime. You can do this in a single tenant or multi-tenant environment. Libraries can be partitioned, so you can have different departments. For example, in a university, you might have a sports operation that wants to store petabytes of sports video from their winning college football team, and by the same token, you might have a physics lab doing world-class experiments that are storing petabytes of research information that they need to preserve in perpetuity. So these are just some of the benefits, in addition to, of course, data sovereignty being key. You know where your data sleeps at night, and that's great comfort in this world in which when data is distributed in the cloud, you don't always know where that data resides, and that does become a problem. So I think those are kind of the big pieces that we see around what we're doing. Our focus, of course, is on making tape much more accessible in this modern world that we live in and put it out there in a cloud consumable fashion.
Yeah, thanks, mate. It's really, really fascinating what you folks are doing here. And as you say, whether you know it or not, tape is already kind of ubiquitous, right? It's used across the board by pretty much any organization that's doing anything of any substance with cloud providers today. So some of the innovations here, I think, are really, really fascinating in turning this into a service that really opens up some of these capabilities to a much broader audience and surveying a range of emerging and evolving kind of use cases. Let's let's talk a little bit more about costs. You've hinted at this a couple of times already, Mitch. And as we've seen, our own research says that suggests that although public cloud can seem like a low cost alternative at first blush, in reality, there are multiple ways in which costs can start adding up, especially when you begin operating at scale. And Mitch, I know you folks have done some of your own work in this space. Um, Take us through some of the things that you found here.
Sure, Simon. Happy to take a look at it. As you said, we've been doing quite a bit of studying of the economics here of cloud archive and retrieval, and we've uncovered some surprising things. And when we share it with customers, it's actually quite eye opening. I'll go through an example here very quickly using Amazon S3 Glacier storage services. Many people are familiar with that because they may use it today or that they have looked at it in the past. But I want to point out that this model or this concept applies to other major cloud providers, including Microsoft and Google, for example. So, really, all of the data that you would put in cold storage, which is what the Glacier storage service is really all about, have to transit through the rest of the cloud infrastructure. And as it transits ultimately to that Glacier storage tier, it incurs charges. It's almost like running the meter in a taxi cab, where it's not a fixed charge; it's a variable charge, and the clock runs when you're stopped in traffic at a traffic light. So, having said that, as the data actually enters the environment on its way to the Glacier tier, it first has to land at the Amazon S3 tier. And there are a couple of different classes of service there. You can see two different buckets. On the right is the S3 standard uh, infrequent access tier, which is meant to be a lower class of service. And to the left is the S3 standard tier, which is the highest level of service available. Any data that flows through that layer on its way to Glacier actually incurs a 1 month minimum charge as it transits. So even though the data is ephemeral in that sense, the charges are there for a month, and they range from about $12.80 per tebibyte. So we're using binary calculations here because that matches the way that people think about their data in the real world, even though the advertised prices are typically advertised in terabytes. So, in terms of TIBs per month, it can be as high as $23. And so, if you think about moving a petabyte, that adds up pretty quickly in terms of data just transiting that layer. It then kind of moves from there, and you need to think about the size of the objects that you're placing because every time that you write a piece of data that lands there, you're making an API call, and there is a charge for each API call, and that amounts to between $5 and $50 for a million API calls. So imagine you're moving a million objects, and each of those objects has a differing size. So the size of the object that you write directly influences the number of API calls, and therefore the costs are variable. The costs are also variable based on the number of objects moving. And so the more you move, the less it costs per object. But that is a hidden cost that you need to factor in. In addition to that, there's a separate charge for all of the metadata that goes along with the object, and each object that you move records 8K of metadata that is placed into an S3 standard bucket, and you're going to have to pay for that at S3 standard prices. So these are some of the hidden costs just on the inbound side. Once it flows through the S3 layer and it lands at the Glacier tier, there are different classes of service. I'll just build these out for you. There are three different classes of service. On the right is the deep archive. That's for your coldest data, and it obviously has the lowest cost at $1 per tib per month. The flexible retrieval tier, faster access times, but a more expensive cost at 369. And then ultimately the instant retrieval, which is your millisecond access class at $4 per tib per month. Now, metadata also gets charged separately at this layer. And so there's 32K of metadata for every object that is archived in any of those S3 Glacier buckets. And so you've got charges for that as well. So this is a pretty substantial adder in the grand scheme of things when you start to scale into multiple petabytes or even into the hundreds of petabyte kind of archival. Now, let's think about what happens when you go to recall that data. To get it back from the Glacier tier, it once again has to be retrieved, which here for the deep archive is at $20 per tib. And $10 per tib at the flexible retrieval, and $30 at the instant retrieval level. So if you kind of look at the cost of retrieval versus the cost of storage, if you will, they're designed to be differing combinations to meet different needs. If you're basically someone that is using the S3 Glacier level for data that might be slightly warm, perhaps an active archive, you're going to want to probably select something that has a lower cost for retrieval because you're doing it more often, even though it has a higher cost of storage for the data that is static. If you don't expect to access that and don't have a need to pull it back quickly, then obviously the deep archive tier might offer the most attractive option overall. And if you need the fastest access time, then the instant retrieval tier is probably more what you're looking for here. Now, there's a 1 month charge when you bring it back because before it's returned to you, it once again goes back into the S3 layer and it is charged at a minimum of 1 month in the same way that it was charged on the ingress. The egress is charged as well. So that adds another cost multiplier every time you access the data and, of course, all of your API calls. Now, to actually get it out of the Amazon environment and deliver it perhaps to where you need to do some operation on it. Let's say you're doing some analytics in the cloud and you need to move that data. Depending on the way that you do that, there are different methods available in the Amazon environment that have differing cost ratios also measured per tib. And you can see that they range here in this example from a low of about $31 in the highest volumes using the direct connect method to as high as $138 if you're using the managed NAT gateway method to do it. So these are very substantial costs here, and all of these items in red are not really that easily apparent. Now that you understand them, it becomes very difficult to calculate it based on your use case. And so we've gone on to do quite a bit of work there, Simon, as well, which I think we're just about ready to show that work off.
Yeah, well, first off, I mean, a really fascinating overview there, Mitch. Really brings home how quickly some of these costs can add up, and also just that they're not always kind of massively visible that these costs are there in the first place. Now, as you hinted at, I know that you folks are making this a customer facing tool as well. So this isn't just something theoretical. Customers and prospects can work out how much they could potentially save with a different approach, right, Mitch?
Well, that's correct, Simon. So beyond just the slide that illustrates where the hidden costs are there in the workflow, we've actually built a tool that calculates this for, in particular, the Amazon service. To continue with the example, so as you mentioned, Simon, we've recently been developing some internal tools that we've been using both to educate ourselves widely as an organization, and we've been using them with our customers as well. And I think many of the reactions from customers are, "This is amazing." And I'll walk you through what this tool does here in just a second, because it actually lays out the exact costs for various workloads for backup applications and archive applications. And we call this the clear calculator, the cloud economics of archive and retrieval. And so in this particular example, all of the light blue fields here to the left of the screen are inputs that the user is able to control. The cloud provider in this instance for this tool is AWS. We do have other models under development for Microsoft and for Google as well. And it allows us to do things like select the geography of the cloud provider. Obviously, with Amazon, there are different locations of their data centers. So we can choose a cloud geography, a cloud region. If you're a large consumer, you may be getting a discount that you can specify. And then we also offer different views of how the capacity is used, both a static state, for example, which is once the data is placed there, it's really stable, it doesn't grow, and it's not accessed again. And then there's a steady state, which might be common in a backup application. Imagine a grandfather, father, son strategy, where once the backups are placed out there, that you're rolling off perhaps a petabyte a month of backup data while you're putting a petabyte of new data in. And so you've got a pretty steady ebb and flow in which data is going in and data is going out, but that the overall storage space is relatively the same size. So just using this example, these are the default parameters that you see here, illustrating the US Eastern region for Amazon, which the cloud region is Northern Virginia. We'll assume no discounts, so the list pricing that they advertise, and a static state where we put data in once, and once the capacity is reached, that we have a particular cost. Under the capacity, you can specify two types, what we consider to be a warm tier of capacity, data that you might want to recall back as it starts to cool down to its ultimately final frozen state, and a cold tier capacity. Here we specified in TIBs, so 1024 TIBs is actually a pebibyte or petabyte of information. So a simple example here, and we get to select the various types of cold storage. We can select the storage class, for example, if we want it to be on the deep archive tier, the instant retrieval, or the flexible retrieval. And so I'll just select the deep archive tier here, which is the lowest cost. We can specify a retention period in a number of years, and then a ramp up rate at how long it's going to take us to ingress all the data. And in this example, it's simply a month. The object size gets specified as well, and this is directly germane to the API calls. Backup applications typically use a relatively small object size, for example, a 1 megabyte object size, while archive applications might use much larger sizes, around 16 megabytes. So the larger the object size, the fewer the number of API calls, and that has an effect on the overall costs. So using that example, we can roll down to the tables here on the left, and so here you can see it just reiterates what we've entered. We have basically no warm storage, only a petabyte, if you will, of cold storage. And under the deep archive option, where the restore time is typically between 12 and 48 hours. So this is your lowest performing service, but your lowest cost, that your itemized costs come down to the actual storage at $1 per month, the API call per 1,000 objects of 5 cents, and then the cost to restore it at $20.48. Over 5 years, your monthly cost for that storage, if you're not doing any restore, is $2.45. But as you increase the amount of restoration activity up to about 5%, you'll see that that $2.45 becomes $14.26. Over 5 years at the bottom here, you'll see that your costs range from $150,000 with no restore all the way up to $876,000 at a 5% rate. On the right side of the screen, we have one more parameter we can specify, and I'll bring this into view here, is that we can vary the restore rate and actually see a 10-year cumulative cost summary. So with a 1% restore per month in this example, using the same petabyte of glacier capacity without any warm storage capacity at the S3 tier level, you can see that in your first year, your annual cloud cost would be $120,000 and your price per TIB per month, $9.78. Why? Because this is the period of time in which all the ingress occurs, and all of those hidden costs we talked about become very high. You can see the API fees alone represent the lion's share of that first year cost at almost $67,000, and the landing zone another $25,000. In year two, that stabilizes, and so you can see steady costs at 165K, um, sorry, steady costs at $44,500, and the cumulative cost here in row 43, that out to year 10 will have cost you $520,800, and you can see your varying costs on a monthly basis. So using this tool, you can enter almost any case that you want. You can model backups, you can model archives, you can model different retrieval sequences or retrieval times to get yourself a view of what it actually costs you over the life of that data, and be able to use this in your own environment to get your arms around those escalating cloud costs for your various warm and cold storage applications.
I think what you've built there is really quite compelling there, Mitch. Is this something that customers are using now?
Well, so up until now, we've been exclusively using that, where our members of our systems architecture team have been using this in consultations with customers. But the overwhelming response when we show these costs to customers using their own real data about their own use of these cloud environments, they've been number one, astonished at the granularity of the data that we can present, but they've asked, could they get a copy of the tool? And so we decided that that was really a great request, and certainly a great benefit for these customers. And so we are making this tool available to customers, as well as folks on this webinar today. And so for the free for the asking, this tool will become available very shortly, and you can use it self-guided, certainly with support from Spectra and our team, if you wish, to model your own cloud costs. Uh, Beyond that, additionally, if you're interested in the on premises object based tape as an alternative to your cloud, then we can also compare your costs directly against the exact same scenario using object based tape, so that you can see the substantial difference in the pricing of using your cloud storage today versus using object based tape.
Super. That sounds like something that I think many people are going to be taking advantage of. Now we are coming up on our time. This has been a really great discussion with some really super and compelling perspectives. As we just wrap up here, what are the handful of things that you'd like our audience to leave with today in terms of, we've covered a lot of ground, but what are the one or two things that you'd like to leave our audience with today?
I think the key takeaways throughout the conversation, from my perspective, that I would want people to keep top of mind are really three things. As AI becomes ubiquitous, and clearly we're moving in that direction, it will deeply integrate into all levels of society globally, and certainly throughout the IT environment. Users are going to need to consider how they'll manage their archival data or their mandated retention data at a level of scale that we simply have never seen before. It's unprecedented what we expect the scale to be. And they're going to need to understand how to maintain that in a secure manner, number one, a sustainable manner, because we have parallel problems with finding enough energy to support all of the online storage that's being used today. And lastly, but certainly importantly and germane to the cost of cloud, is a cost effective manner. Tape, as we've talked about today, does satisfy all of those requirements. And now it's easier to adopt than ever because of cloud-like interfaces created through things like object-based tape from Spectra. The second point is that, as I mentioned power briefly here, we're in a power crisis. We are starting to find that the demand for power supply is growing at a faster pace than new energy sources are coming online. And so, anytime you have a supply and demand imbalance, organizations are going to have to make some trade offs. Sometimes they move to the cloud, which really moves the power problem to some other physical locality or makes it someone else's problem, i.e., the cloud provider. But organizations that are doing things on premises are going to have to think about allocating their power. What will they allocate their power to? And I would argue that they're going to want to allocate that power to the thing with the greatest probability of creating business value for them, which would be scaling their AI infrastructure to remain competitive or to get a competitive advantage. So when you think about there is no more power available and I need to scale, and the idea that AI servers or GPUs consume as much as 14 times more energy than current conventional server technology, that using tape to reduce the power profile is a way to conserve energy that can be reinvested in growing that infrastructure. So if you have 80% typically of your data that is cold, and we've seen statistics that go as high as that level, that cold data becomes a candidate for retention on tape. As you move that away, that frees up a lot of your spinning disk infrastructure or your flash infrastructure, perhaps, and allows you to reinvest that power in growth. And so I think that tape becomes part of your sustainability strategy and part of your growth strategy directly for AI. And third and finally, I think that cyber threats will continue to escalate, especially in the era where cyber criminals are being assisted by AI tools, and that tape, through its air gap technology, encryption, and other methods, offers the greatest resilience, which is unlike the online storage or the cloud storage that folks use today.
Yeah, great stuff. Thanks, Mitch. We didn't really get a chance to dig into the power aspects, the sustainability aspects. Maybe we dig into that in more detail in the future session. I feel like we could spend a good chunk of time just on that topic alone. But yeah, three really compelling takeaways there. Thanks again, Mitch. Just finally, where can our audience go to learn more about all the things we've talked about today?
Well, great, Simon, and thank you so much for the conversation. I agree there's much more to explore, and we'll do that perhaps in a future event. So, for more information, you can visit spectralogic.com and learn all about our object based tape solutions as well as our many other products and solutions. If you're interested in getting your own copy of the Clear calculator that we demonstrated to do your own analysis, you can actually learn about that. We'll be sending a follow up email to everybody that attended the webinar today. And in the future, if you're watching this on replay, that'll be available as well. And that will allow you to get your own copy. We would love to live chat with you at spectralogic.com if you have any questions. We do have humans as opposed to chat bots that would be more than happy to engage with you. And they're friendly, I promise. And they'll be certainly interested. And you can, of course, subscribe to any updates at spectralogic.com or follow us on social media through all the usual channels.
Fantastic. That's great. Well, thanks again, Mitch. This has been a really great and informative session. Thank you again. And the only thing that's left for me to do is to thank our audience for joining. So thank you, and you have a great day.